thirds. Do you guys see that the sign was going back and forth and back and forth and back and forth and back and forth? We call it alternating, and it was going down. But if you set up the ratios, no problem. Number 14, you were finding the first 5 terms. Boom, 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 boom. Number 24, you were finding the first 5 terms, but this one, they wrote it a little bit differently. Instead of giving you A1 and the ratio, they gave you A1 and a recursive formula. You guys remember what recursive formulas are? They tell you how to get a latter term by using the prior term. So how do you get a sub 2? Well, a sub 2 is 1 plus 1, so you use a sub 1 times 1/3. Boop, boop. To get a sub 3, you use a sub 2 plus 1 is 3, so a sub 2 times 1/3. Oh, you're just multiplying by 1/3. There you go. It is a geometric with a sub 1 being 81 and common ratio being 1/3. Whoa, 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 whoa. How'd they make that jump? They didn't do n, well, they did do n minus 1, but how did they do n minus 1? Do you guys remember how exponents work? Do you remember how exponents work? This is something that Calc BC has been struggling with a little bit. If I have 81 times 1/3 to the n minus 1, what does subtraction in the exponents show? Division. Subtraction in the exponent shows division. So wouldn't this be the same thing as 81 times 1/3 to the n over 1/3 to the 1? Wouldn't that give you n minus 1 when the bases are alike and there's division? Wait, but how do you divide by 1/3? Oh, you multiply by 3 over 1. And what's 3 times 81? 240, 3, 1/3 to the... Ooh, that's like a nicer simplified version of your original. Now do you see why it's 243 times 1/3 to the n? They made that minus 1. Wait a minute, that minus 1 just means divided by 1/3. I can put those two together. All right. Number 40 gives you the first and the second and the third, and by division we figure out the common ratio is 12. But then they ask us for woo-hoo-hoo, the 7th term. And instead of doing times 12, times 12, times 12, whatever in your calculator, they use the nth term formula, and you get 8,957,952. Number 48 goes to letter C, because it's bouncing back and forth and back and forth, and because of the 2/3, it's getting closer and closer to 0. Number 62 was a little bit intense. Now, the actual formula itself up here, if you were just plugging it in your calculator, you would have gotten fairly quickly to 12.5. However, they wanted to see, or have you see, that it was a geometric series. It was a geometric series with a 5 every time, and with a 3/5 to the n. Now, some was a little bit confused when you went to plug in. They plugged in a weird way. They decided when they started writing it out, they were like 5 plus 5 times 3/5 to the 1, 5 times 3/5 to the 2, 5 times 3/5 to the 3. We get rid of the stupid pop-up ads that keep on popping up. I guess that's what pop-up ads do, huh? But, coming back, sorry about that, I apologize. They decided to have that 5, since he didn't have a 3/5, to have him be his own dude. So he was kind of his own dude for the rest of the time. He was sitting and chilling out while they were doing this guy as the geo series. Could have technically also made this a part as well. He would have been your a sub 1 or your first term. That would have confused a few of you. So they went ahead and made it a little bit weird, but it did work. The other way of doing it without doing that weird 5 plus on the outside would have just been to write out that sequence or that series of terms. Guys, even if we keep the 5 in there, isn't R 3/5 every time? Right? Isn't it times 3/5 times 3/5 times 3/5 times 3/5? Couldn't we have done S sub, what were they asking for? From 0 to 40? Wait a minute. Don't our sequences or our series, sorry, these are additions, don't series usually start at 1, not at 0? So how many terms would there be? If 1 to 40 is 40 terms, why did they do 41 down here? Yeah, 1 to 40 is 40. If there's a 0 also, there's actually, if you were to write them all out, there's 40 here and another 1. So it's a little awkward, it's a little weird. But if you had seen that weird sigma going from 0 to 40, you needed to realize, oh, wait a minute, that's going to be S sub 41. There are 41 terms there. And then you could have done your A sub 1 as 5, and then 1 minus 3/5 to the n, which would have been 41, all over 1 minus 3/5. You could have done it this way. It should have ended up still with 12.5. But either way, you would have needed to go to your calculator still because, yeah, I'm not raising 3/5 to the 41. Hold on, pause. What is 3/5 to the 41? Can anybody do that? 0.6 to the 41 power? I'm pretty sure it's pretty small. I'm pretty sure it's pretty small. And as you guys figure that out, I'm going to go ahead and play with this just a little bit as you're trying to figure out what that guy is. So I'm going to do 5 times 1 minus whatever that weird 3/5 to the 41 thing is. I can do this down here. That'd be 2/5. And 5 divided by 2/5 would be 5 times 5/2, all times that 1 minus the weird 3/5 to the 41 dude. And then that ends up being 25/2 times 1 minus the weird 3/5 to the 41 dude. Wait, isn't 25/2 the same thing as 12.5? Question, how much difference did the 3/5 to the 41 power make in my answer? Absolutely none. Why? What was 3/5 to the 41? 0.00. Oh, I bet they did scientific notation. Times 10 to the power of? Negative 10. You mean there's 0.000000 before numbers come? So what is this ultimately? 0. Why? Didn't we talk about on Friday with geometric series that infinite geometric series, if r is in between 1 and -1, any fraction, positive or negative, that doesn't quite make it to 1, what's always going to happen as we raise that ratio to higher and higher and higher, 10, 20, 30, 100, 1,000,000? It's going to get closer and closer to 0, aka having basically no effect, aka, oh, that's why I didn't even really need to put that in my calculator. I could have just said 12.5. That's kind of spiffy. All right, going back to the answer key, Lo siento, I got excited. That's 12.5. Number 70. Number 70, it took them a while, but they figured out eventually that this -3 over 625, it took 6 terms to get there. So you wanted to find the 6th partial sum. And so you could plug into your summation formula that we saw on Friday, how to go from an S sub n to, wow, he's frozen. Okay. How to go from an S sub n to an actual sigma. That's what they did, and they plugged in. Number 78. Oh, wait. Why didn't they end him? What's at the end of the series? A dot, dot, dot that says keep going and going and going and going and going and going. So was there an ending point? No. There was here. There was not here. So just go to infinity. And then why did this work? Because r was equal to 2/3, which meant this was a convergent infinite geometric series. So I could plug into my nifty formula. Well, not that one. That one, if you ignore that piece, which was the one we were just looking at, a sub 1 times 1 over 1 minus r, when you ignore that little dude, to 0. So plugging in, you get 27. 9 over 1/3, 9 times 3. Dun, 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 dun. Questions on odds or evens? Vico. 81. Tony. 70. And then Gavin was the same. Let's start. 17 or 70? 70. Okay. So number 70, let me get to the book real quick. I think I have it open right here. 70 was, oh, the nasty one where you're trying to figure out what term it was. Okay. There were 2 ways of doing this. One was very experimental, find the pattern, and one was very mathematical, use the formulas. So let me show both because some of you are much more experimental. Find the pattern, Aiden especially. Some of you are much more use the formulas. Give me a formula, I want to use the formula, I don't want to have to think outside the formula. That's kind of a lot of the rest of you. Not all of you, but a lot of the rest. Number 70 said, I'm going to give you the sequence of, it's really tiny over here, so let me get it down. 15 minus 3 plus 3/5. Did anybody find the pattern just by like looking at it? Yeah, it is going to be times a negative because negative, positive, negative. And then r is equal to negative 1/5. Okay. So here's the experimental way. The experimental way is to say 5 to 625. I feel like I could do that. The experimental way says, okay, hold on. Let me zoom in here and say, okay, so if 15 is a sub 1, if negative 3 is a sub 2, if a sub 3 is 3/5, what would the next one be, guys? A sub 4 would be negative 3 over 25, right? A sub 5 would be positive 3 over 125. Ooh, hey, look, it's a sub 6. So maybe some of you realize that 625 wasn't all that far away from 5, and you're like, oh, times 5 times 5 times 5, psh, I can do that. So you could have technically plugged and chugged that to your calculator. You could have technically set up a sigma and said, okay, well, if I start at 1, I'm ending at 6 with my first term times my common ratio, according to my card, my formula from the notes, to the n minus 1, right? So you could have plugged that to your calculator after having found the missing pieces. You could have plugged this to your calculator after realizing the pattern. But just some of you were trying to be really good and use your formulas. So your formulas would have said, okay, well, you don't really know the in-between, and we're not going to have you find all the in-betweens. So you would have had to say a sub n, which equals a sub 1 times r to the n minus 1, needs to be negative 3 over 625 when I'm starting at 15 and multiplying by negative 1/5 to the n minus 1. Now, first of all, I don't like that my n's here. And I don't like that there's a minus 1. So a few things that I would do with this formula. One thing is you could take that really cool trick that we just saw, that subtraction is division, and you could actually make this times negative 1/5 to the n all over negative 1/5, because that would be the n minus 1 according to my formula of plugging in the a sub n term. Isn't dividing by a fraction multiplying by the reciprocal, guys? So then I could say negative 3 over 625 is equal to, so I could multiply by negative 5 over 1. But I have to do that top and bottom, negative 5 over 1. 15 times 5, isn't that a 75? So I could do negative 75 times negative 1/5 to the n. I could divide by negative 75, which to be honest is really quite gross, right? Yeah, because dividing by negative 75 ends me up with a positive 3 over, I don't know, something big, 75 times 625. But what do I have chilling over here? Negative 1/5 to the n. Now, wait a minute, hold on. Doesn't 3 and 75 reduce? Oh, that's nice. So it's not as bad. And 625, hold on, 625, isn't that a power of, okay, yeah. Can't I say that 25 is 5 squared? And 625, if we were to break that down, if we needed to, we could have off to the side. You could have said, okay, there's how many quarters in $6.25? Isn't that 4 times 6 is 24 and another one, so 25? Oh. Well, that's nice. Isn't that just 5 to the power of 4? So without using a calculator, guess what we could have done? If we had just broken down our numbers carefully. We could have figured out that this is to the power of, isn't this the 1-to-1 property, kiddos?
Wait, what? And 625 versus 86?
N equals 6. And as soon as n equals 6, we can come back up here and we can go ahead and plug 6 into our sigma. And if you wanted, we could have done this the other way of s sub 6 is equal to the first term times 1 minus the common ratio raised to the 6th power all over 1 minus the common ratio. Either way you could have solved. Sorry, that's number 70. I have that guide right here. We can go back and look at the final answer. They went ahead and, oh, you were just writing it in a sigma? Oh, all right. Well, never mind. I was having fun in solving. That's a sad day. Anyway, what was the other question? Sorry, number 81. Ah, the repeating decimal one. Repeating decimal ones. Not too bad if you do them carefully. But what I do for repeating decimal ones is I actually start writing the repeating decimal. And I say, okay, it's 0.36, but then isn't it plus another 0.36, but a couple decimal places away? And then plus another 36, but a couple decimals away? If I had, or if I was to rewrite this guy, repeating 36 is a 36 and another 36 and another 36 and another 36. Do you guys see how I'm doing my little progression? 36 hundredths and then 36 ten thousandths and then 36, I don't know, something a lot bigger. What's my common ratio? My decimal is moving how many places every time? 2 decimal places, which means I'm dividing by 100 every time. Oh. So couldn't I say that a sub 1 is equal to 0.36 and r is equal to 1 over 100? And if I'm trying to get the infinite repeating decimal, I'm trying to find the sum, which is the limit as n goes to infinity, of my a sub 1 times 1 minus r to the n all over 1 minus r. I could actually like make my formula again and be like, you're going to 0. Or I could use my yellow card that we talked about on Friday in our notes that said we can just jump straight here as long as we know it does exist. So either way we end up at, now here's the problem. You're supposed to be doing this without a calculator. Hey guys, what's 1 minus 100th? How many hundredths are left? 99 hundredths. Wait, if I'm dividing by 99 hundredths, isn't that multiplying by 99 over 100? Oh, no, by the reciprocal. 100 over 99? Oh, that's gross. I don't want to multiply it by a decimal. You don't have to. Why not multiply it by 36 over 100? Oh, then the hundreds cancel, and I have 36 over 99, and I say I think 3 goes in. Doesn't 3 go in 12 times and 3 go in 33 times? Oh, 9 goes in. What? You can go even by another 3? 4 over 11. Dun, 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 dun. That was fun. Kiddos, I want you to grab out your notes and get ready for section 9.5, the binomial theorem. But first, I cannot leave geometric sequences in series without showing you one of the best geometric sequences in series videos of all time. Notes open. Is not minions. Shh, focus. She talks fast. Jason, come stand up over here. Oh, hold on. This is so sad. I turned off the sound so you guys couldn't hear it. So I want you to multiply one more. What's the one that's missing? Oh, I guess I'll do that one for you. That's hard. Okay, go. What's a plus b to the 1 power? What's a plus b squared? Ooh, don't kill a puppy. That means you'd have to FOIL a plus b times a. What's a plus b cubed and a plus b to the 4th? Let's see if we remember.
No.
Ah, how to do polynomial multiplication? Come on, party poopers. That's like algebra 1. It's okay. I'll play with it up here as you play with it down there. But not with this marker. How about this marker? Ah, much better. How are you guys squaring a plus b? No puppies will be killed in this problem. True? Hmm. True? Okay. But how do we then do another A plus B? Oh, nice. Okay. So that would be, well, we just do lots of distribution, right? Like A goes to everybody and then B goes to everybody, right? It's not that big a deal. True? So we get A cubed plus 2A squared B plus AB squared. But then we have all the B's. And then the B plus A squared B plus 2AB squared plus B cubed. Oh, that's interesting. There's one A cubed and one B cubed. And then AB squared and 2AB squared and 1AB squared will be 3AB squared, and 2AB, or A squared B and 1A squared B. Interesting. So that's going to be A cubed plus 3A squared B plus 3AB squared plus B cubed. All right, no stress, guys. We only have one more. So how are we going to do one more? Yeah, take that guy and multiply by an A plus B. Swoop, 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 and combine like terms. Yeah, it will be. It's all in my head. You're welcome. Wait a minute, but I didn't write anything on the board. Where's my polynomial of 4 terms and my A plus B and all my distributions and combining of like terms? What? What's the pattern? There's a pattern. I wonder if there's a pattern of the coefficients as well as a pattern of the variables. What would happen if I took just the coefficients? Make it a little bit nicer. What am I doing? Pascal's triangle. What would the next power of A plus B be? If you guys were to try to do it mental math, meaning you're not really doing the multiplication, a pattern going with it. What would the coefficients be? 1? 5. 10? Do you guys agree? You just add. So 1 plus 0 is, maybe there are just 1s on the outside. But then anything inner is going to come from the ones above. So 2 is 1 plus 1, and 3 is 1 plus 2, and 3 is 1 plus 2, and 6 is 3 plus 3, and 4. Are they just branching out? Then was Kyle right with, and those of you that were helping him with 1, 5, 10, 10, 5, 1. Oh yeah. So what would the variables be to match it? Did you guys see a pattern of the variables? What would A's power be? Oh. What would the next term be? What happens to A every time? It decreases. So could I put an A cubed and an A squared and A terms? What's going to always happen at the end? Gone. A to the 0. So how do the B's get in? The first term only has A's. Where does the B start? Second term. So this is going to be B to the So that was b to the 0, b to the 1. Who's this guy going to be? The third term always has a b squared. Oh, so b is counting up? What's this one going to be? And this one? And this one? You guys are exactly right. So here's a question. As I write the findings over here, like, in our actual notes, we have a plus b, a squared plus 2ab plus b squared, a cubed plus 3a squared b plus 3ab squared plus b cubed, a to the 4th plus 4, a cubed b plus 6, a squared b squared plus 3ab cubed plus b to the 4th. And we did more on the board. What if I was to ask you for, something like the a plus b to the 10th term. What's one way? The third. On the triangle, you'd have to do a few more rows, and every time you there's the coefficient piece, right? That we're a little bit. But there's also the var piece. It starts to the 10th term, but isn't that the first term of the sequence or of the sum? It'd be 9, 8, so a would be to the 8th. What would be to the 2? Oh, this is interesting. 8 plus 2 is 5. 4 and 1 is 5. 3 and 2 4. 3 and 1 is 4. 2 and 2 is 4. Huh. Got it 8.5. Like boom, to like papers on the side. What do you guys see in this yellow box up here on the page? What? So there's more than Pascal's triangle? Who's this dude, and why is he just chilling in the coefficient spot? Like, I thought we needed Pascal's triangle to get the coefficient. What does the binomial theorem say? To expand a binomial, x plus y to the n. Okay, I get it. The first guy starts off to the highest power and counts down. The second guy starts off not there and counts up. Like, okay, I kind of get that pattern, but who's this NC? Oh, hey, there's the formula for NCR. And it uses factorials. This will be exciting. Literally, look at all those exclamation points. But anyway, what else? Is this guy in your... Wait a minute. Hold on. I'm trying to find the coefficient of the third term of the a plus b to the 10th expansion. Do you think I could actually do that using this formula? Who's the N and who's the R? Like, I could actually plug this in and not have to do Pascal's triangle. Guys, wait, this is a good thing, right? So what if I was to insert a page and then I do a dual page? Okay, so I'm trying to find the third term of, a little bit lazy at least, we figured out it's 8 to the 8th and b squared. We're trying to figure out this dude, and over here in this formula, it says NCR. Well, hold on. Can you guys see what n is according to, oh, hey, n is the power. So can't I say that n is just 10?
Yeah.
Okay, and what's r? I see the r like with the y guy, right? So with the y, that would be with the secondary dude, and the secondary dude is b, right? Sweet. So what can I say about this term? It should be not 8. Lo siento. What's my power? 10. C, 2. And I for 10 factorial all over 10 minus 2 factorial, which will be 10 factorial. Oh, man. Factorials, though. I have to go to my calculator because I have to do 1 through 8 and then 1 through... Wait a minute.
Hold on. It's just 1.
If I have 1 through 8 down here...
1 through 2.
And 1 through 10 up here, wouldn't that go to 8 and then go to 9 and then go to 10? And then I have my 1 and 2. Don't all the 8s just go away?
Yeah.
Don't I just have 90 over 2? What's 90 over 2? What should happen if you kept on going all the way down to the 10th row and you counted over 3 spots? Well, that's the 10th term of a plus b to the 22nd. Oh, we're going to start having fun on this one tomorrow. Bye, guys. See you later, alligators. After a while, crocodiles. Binomial theorem. Part 1 done.